Right, solving, well, inequation, inequality. Hang on, which one is it? Inequation or inequality? What is the difference? Okay, an inequation is something that you solve to find set numbers, whereas an inequality is something you prove. So it might be something you prove for all numbers or something like that. So it's a subtle difference. Okay. Now, whenever we're trying to solve this sort of inequation, sometimes it's easier to solve left-hand side minus the right-hand side greater than 0. Because sometimes that's just an easier thing to find. That's also true for inequalities as well when you're proving that. Sometimes it's easier to prove something's always positive or something's always negative. Reason why? Comes down to critical points. See, when does something change from positive to negative? That's always an easy thing to find. It's like x-intercepts on your graph and things like that. And the key things about when functions change sign, it'll only change sign at an x-intercept. So if we're looking at the graph, x-intercept, it could change from positive to negative. But the other place it could do it is if there's a discontinuity in the domain. So like the hyperbola. Okay, at x equals 0 we have a discontinuity. On one side it's positive, on one side it's negative. So the actual graph can change sign. But they're the only situations where it will change sign. Now some notation, bracket notation. So if you have a bracket, then the interval endpoint is included. If it's a parentheses, then the interval endpoint is not included. So it's an alternative way of writing solutions to inequations, or also domain and range for that matter. So if I had something like that, where it's bracketed at both ends, then that would be a closed interval. So both endpoints are included, as opposed to something like this, where we have parentheses at either end, and that would be an open interval. And that's when none of the endpoints are included. Unbounded is if it would go off to infinity in either direction. So there is no boundary. So something like x is greater than 5, and there it is on our number line. That is an open, unbounded interval. It goes off to infinity and the endpoint's not included. So I could write that there like so. So 5 and infinity. And notice on the infinity end, whilst infinity is the theoretical endpoint, you of course can never get there. So it's not included. So that's why we have a parentheses there rather than a bracket. Another way we could write that in set notation would be all the x values such that x is greater than 5. Basically it's the same as the original equation, you'll notice. So x is less than or equal to 6, which would look like something like that on the number line. Now, it's going to be closed unbounded. So again, it goes off to infinity, but the endpoint on the other end is included. So that one we would write with a bracket at the 6. Then x is in between 4 and 6. Well, that one's open, because the endpoint's not included, but now it's bounded. It does have a boundary that it exists in. And so that one would be, the reason I don't necessarily like this notation, you've got to know, oh, hang on, I'm not talking about the 0.46. You could confuse that with a coordinate, but it looks exactly the same. And this one here, that one will be a closed bounded interval, because both endpoints are included. So we'd write it like that. Okay, what about one where one endpoint's included and the other's not? So that's just a bounded interval. We don't call it open, we don't call it closed. We just say that's a bounded interval. And one's like this. So it's got a couple of solutions. Well, that's just the union of two intervals. And so we write that with the union symbol. We're saying it's these two intervals, the union of them. Okay, composite functions. Remember that? So when two or more functions combine to create a new function, f of g of x also can be written as fog. Right? Well, it looks like it's saying fog. F with a circle, g. So that's when we substitute g into function x. So function x is 2x on 4 minus x. G of x is 1 on x squared. Then fog would be substituting 1 on x squared. And we end up with, there it is, 2 on 4x squared minus 1. Whereas goff is 1 on 2x minus 4x all squared. And there's our answer for that one. So we're going to solve this inequation. And the easiest way is to find your critical points. So when's it going to change sign? Now for our one, it's nice and easy. It's already factorised for us. So we know it'll be at -3 and it would be at 1 as well. So we know the boundary points. It's just a matter of then testing intervals, or you could draw the graph. But if we tested intervals, we'd find that, oh yeah, subbing a number on the left-hand side of -3, it works. But nothing else works other than the point 1. So we've got x is less than or equal to -3, or x is equal to 1 is another possibility for that solution. So pronumeral in the denominator. And we've seen a couple of ways of doing it already. But using this idea of left-hand side minus right-hand side, and we can create a complete fraction on the left-hand side, and using that idea of it'll only change sign at x-intercepts or discontinuities. Well, the top of the fraction will give me any x-intercept, the bottom of the fraction will give me any discontinuities. So we have -3 and -13 on 5 as our two possibilities there. And again, we just test values, and for this one we find, yep, we're on the left of -3 and we're on the right of -13 on 5. There's our solution. 3A.